Okay, 6.10, we're going to integrate functions using long division and completing the square, and these are just some other strategies you could use to integrate a function. So this one says use long division to rewrite the integrin. The degree in the numerator is higher than the denominator, so that's what's going to tell me that I should probably use long division. Because the denominators of the form x minus or x plus, I could also do synthetic division, and that would work equally well. But let's do long division for now, and I'm going to remind you how to do it if you have forgotten. Okay, so I'm dividing x minus 2 into 3x to the third minus x squared minus 5x plus 4. Put this in standard form. If you're missing a term, put a 0 as a placeholder. Okay, let's try this. Okay, so if you remember when doing long division, you look only at the first term. So I think, what do I times x by to get 3x to the third? I get 3x to the second. Okay, and then I'm going to distribute the 3x to the second times the x and the minus 2. So I get 3x to the third minus 6x to the second. And then I'm going to subtract down. Okay, you don't need to show your subtraction, just show. You just know you're doing it. Okay, so 3x cubed minus 3x cubed cancels. Negative x squared minus negative 6 squared is negative x squared plus 6x squared, which gives me 5x squared. And then I'm going to bring down the next term, which is the minus 5x. Okay, now if I do x to get 5x squared, times it by 5x. Distribute it. 5x times x is 5x squared minus 10x. Then I'm going to subtract down. 5x squared minus 5x squared cancels. Negative 5x minus negative 10x is negative 5x plus 10x, which is 5x. And then I'm going to bring down the 4. And then to multiply x to get 5x, I multiply by 5. 5x minus 10, and then I'm going to subtract down. If I subtract 4 minus negative 10, I get 14. Okay, now my whole goal was just to rewrite this integral in mixed number form. So this is the same as 3x squared plus 5x plus 5. The remainder is 14. And I was dividing by x minus 2 dx. Okay, after all that work, my actual goal is now to take the antiderivative. So the integral of 3x squared is 3x cubed divided by 3 is x cubed. And what is that? 5x squared divided by 2 plus 5. And then I have 14 over x minus 2, which I know is going to be some kind of ln function. Okay, should I do u substitution? I'm going to do u substitution. If you can do this u substitution in your head, I'm okay with this. So now I'm only looking at this term right now. I'm going to let u equal x minus 2, which means du equals dx. So that means I am trying to find the integral of 14 over u du. What is that? That is going to be 14 ln of u plus a constant. So now I'm going to go ahead and put this answer. So it's going to be 14 ln of what was u? X minus 2. And then this is indefinite, so I'm going to do plus c at the end. Okay, and then that's my answer. Now I said you could probably do this in your head. If you know that u is going to be x minus 2, then you know du is going to be the same as the dx, so the u substitution isn't going to mess anything up. So you could skip straight from the integral of 14 over x minus 2 is 14 ln of absolute value of x minus 2. And then don't forget your plus c. Okay, that's my answer. I'm going to do a quick little, what's it called, synthetic on the side to remind you if you prefer that. Okay, this is x minus 2, which means synthetic implies. For synthetic, we plug in the x value or that makes the denominator 0. So I'm going to plug in positive 2. Okay, synthetic, we don't put x's, we put coefficients. So the first coefficient is 3, negative 1, negative 5, and 4. If you're missing a term, you put 0 as a placeholder. I put a dash line to show my remainder. Okay, synthetic, first move is you bring down the 2. Not the 2, you bring down the first term, which is 3. Okay, then I times. 2 times 3 is 6. Oops, sorry, 6. Then I add. Negative 1 plus 6 is 5. Okay, then I repeat. 2 times 5 is 10. Negative 5 plus 10 is 5. Negative 5 is 10. 4 plus 10 is 14. Okay, and then you have to rewrite it in polynomial formation. So this is 3x squared plus 5x plus 5. Remainder is 14. So you can do this and then you get this expression as well. Your goal is just to rewrite it in mixed number format, which is this. How you get there is up to you. Okay, let's try one more like this just to practice. So b, 6x, the integral of 6x squared over 2x plus 4. Since the degree on the top is higher, I'm thinking long division. Okay, so let me do this on this side. And I'm going to divide by 2x plus 4. Now the polynomial inside the division box should be in standard form. It's missing a bunch of terms. So I'm going to put the 0x and the 0 here because otherwise it's going to kind of make my terms line up funny. Okay, and then I'm going to do it the same way I did to the last one. Look at the first term. This times this. I times by 3x. I like to line up the like terms with their column so I know when I'm done. You don't have to. 3x times 2x is 6x squared plus 12x. And then subtract down. So 0 minus 12x. Okay, to get negative 12x, I times 2x by negative 6. And then remember to subtract down. So negative 12x plus 12x is 0. 0 plus 24 is 24. Okay, and then my goal was to rewrite this as a mixed polynomial. So I get 3x minus 6 plus 24 over 2x plus 4. Okay, and if you want to do synthetic with this, you could. There's ways to do it, but because this is not x plus 4, it's 2x plus 4, you have to make some adjustments at the end, so it's probably not worth the trouble, given this isn't a terribly hard polynomial. Let's do the antiderivative. So this is 3x squared over 2 minus 6x plus. Okay, now I want to do the antiderivative of this thing. Could we do it in, we can do it in our head, and I'll show you how to do it in your head. I'm going to do u substitution on the side to show you how to do it. I know it's going to be ln. I can tell that u is going to be 2x plus 4 because du is not going to be the same as dx. It's why you might consider u substitution, although you could do it without. Okay, so let u equal 2x plus 4. So du is going to be 2 dx. Which means dx is 1/2 du. So let's plug that back in. So I'm going to find the integral of 24 over u times 1/2 du, which means I'm doing the integral of 12 over u du, which is going to be 12 ln of the absolute value of u plus c. So this is going to be plus 12 times the natural log of 2x plus 4, and then I'm going to remember to put my constant, which is the c. Okay, now the u substitution, I'm just using it to help me get this antiderivative. How I would do this in my head. If I were doing this in my head, I would look at this and go, this looks like it's going to be 24 times the ln of the absolute value of 2x plus 4. But I can see that the derivative of this is going to be 2, so if I were doing the derivative, I would times 2. Since I'm doing the antiderivative, I divide it by 2, so instead of 24, I get a 12 here. And that's how I would do it in my head. Okay, the next strategy is completing the square. And when you're completing the square, you're normally thinking this is going to be the antiderivative is going to be some kind of inverse trig function. Okay, now I'm going to stare at this. Now, if I try to do u sub on this, I would make u probably be this. The derivative of du would be 2x, and there would have to be a 2x at the top. There is not a 2x at the top. But there's a squared at the bottom. So I'm thinking this is going to be inverse tangent, to be honest. So I'm going to complete the square on the bottom so I can make it into u squared plus 1. Okay, so I'm going to do this on the side. So to complete the square on the bottom, I do x squared plus 6x. I want this to be a perfect square, so I think about what I would have to go here for this to work. I'm going to move the 10 over to here. Okay, to complete the square on 6x, I do half of 6 is 3. 3 squared is 9. So I want to add 9 to complete the square. If I add 9 randomly to complete the square, I need to balance it by minusing 9 over here. This is going to factor into x plus 3 squared plus, what's 10 minus 9? That's 1. Yeah, I'm going to rewrite this integral. Okay, now the reason this is better is because this looks an awful lot like 1 over u squared plus 1 du. The antiderivative of this is inverse tangent. Okay, now should I do u substitution? I'm going to write the answer and then I'm going to do u sub because some of you, at this point, you should be able to skip u substitution some of the time. Okay, if I want it to look like this, that means u is x plus 3. Now du is going to be the same as dx, so there's not going to be any weird factor to mess with, which means that I am probably going to just skip straight to the answer. So I know this is going to be inverse tangent of x plus 3 plus a constant, and that's going to be my answer. And if you skip to the answer, I'm fine with that. Okay, if you would like to do u sub because it still makes you feel more comfortable and you're not totally sure when you can skip it, I would say that u equals x plus 3. So du equals dx. Okay, which means I get up to this point right here. The antiderivative of this is going to be the arctangent of u plus a constant. And I would go back and make my substitution from there. But because I could see what u was and I knew that du was going to equal dx, you could skip it and it would be a good time to skip it. Okay, let's try b. Okay, now again, if I were doing u substitution, I would probably pick this weird polynomial as my u, and then I would get a negative 2x plus 8, but there's no x at the top, so that's not what it's going to be. So it's going to be some kind of inverse trig function. So I'm going to complete the square. It has a square root at the bottom, so I'm thinking it's probably going to be arcsine, which is already like a hint. I'll tell you arcsine would look something like this. And that looks like what it might be. Okay, I'm going to complete this square on the denominator, but there's a weird negative sign which is going to mess me up. Okay, I want to complete the square. I'm going to take out the negative. And I'm going to take the negative out of the positive 8x, so it's going to be negative 8x. And then I know I'm going to complete the square here. And then this minus 15, let me move him off to the side. Okay, this is equivalent to this, the radicand. Okay, to complete the square, half of 8 is 4, 4 squared is 16. I'm going to be careful here, because I did add 16, but it's in parentheses, so this represents a negative 16. So to cancel out the negative 16, I need to put a plus 16, which means that this can be rewritten as negative x minus 4 squared. Negative 15 plus 16 is 1. Okay, now let's rewrite this. And then we're going to stare at it, and it's going to look like inverse sine. So inverse sine is normally of the form 1 minus u squared. So for this, I'm going to put the 1 first. Okay, now that it's set up like this looks like 1 over the square root of 1 minus u squared. It looks like this. If I did u substitution, u would be x minus 4, du would be dx. So the u substitution isn't going to mess it up by a factor. So if you're comfortable, you can skip straight to the answer, which is going to be arc sine of u, but u is going to be x minus 4, and then I'm going to add a constant. Okay, one more, and this one's going to be a little trickier. Okay, but it's going to be the same idea. This is going to represent some kind of inverse trig. Again, if I tried to use substitution, I would let this equal u. Du would be 2x minus 4, and there'd have to be some kind of x at the top, and there is not. Okay, so I'm thinking it's inverse trig. It's probably going to be inverse tangent, only because there's no square root. So inverse tangent, I'm thinking, is going to be something like this. And in my mind, I think about what it wanted to look like so that I know when I get there. Okay, I'm going to complete this square on the bottom. So x squared minus 4x. I'm going to move the plus 20 over. To complete the square, half of 4 is 2. 2 squared is 4. So I added 4. I need a minus 4 to balance it. So this is x minus 2 squared plus 16. Okay, let's rewrite this. Okay, now this looks closer to this, but there's supposed to be a 1 here for this to be arctangent, so I want to create a 1 there. How am I going to create a 1 there? Well, I want to just divide this by 16. If I divide this by 16, I need to divide this by 16, I need to divide this by 16. I need to divide everything by 16. Okay, I'm going to put it to the side, and hopefully it's not going to freak you out. Am I? No, I'm just going to divide everything by 16. That's what I'm going to do. Okay, so I want to make this 16 into a 1, so I'm going to divide this whole thing by 16. If I divide the bottom by 16, I need to divide the top by 16. Okay, let's stare at this and see what it looks like. Okay, so now this is a 2 at the top. Now at the bottom, I have x minus 2 squared over 16, but I do have a 1 here, dx. Okay, now this looks better. There's a 1 here, but I want this u squared to be like 1 quantity squared. So I'm going to rewrite this one more time before I try to integrate it. I'm not worried about the 2 at the top because that's just like a constant. So I'm going to rewrite this as x minus 2 over 4, the whole thing squared plus 1, because now it looks more like u squared plus 1, where u is x minus 2 over 4. Okay, I think I am going to do u substitution on this one because the u of x minus 2 over 4 is going to throw me off a little bit. If you don't do it, I'm okay with that if you're very careful of your missing constant. Okay, so let's let u equal x minus 2 over 4, which remember is x over 4 minus 2 over 4. So du equals 1/4 dx, because x over 4 is the same as 1/4. Let me make dx equals 4 du. Okay, now if I rewrite this in the integral, now what is this? This is u squared plus 1, which I wanted, and then I have times this extra 4, and then I have this du out here. So what do I get from this? 2 times 4? I get 8, and then this is going to be arctangent of u, and then plus c. Okay, so now let me go back and write my answer. So this is going to be 8 arctangent of u plus c. Okay, now for those of you who like to do it in your head, when I get to this step, I'm looking at this and I'm going, that looks like arctangent. I think the u is going to be this. The derivative of this is 1/4. So when I find the derivative, I multiply by 1/4, which means when I do the antiderivative, I'm going to divide by 1/4. If I divide by 1/4, I'm timesing by 4. Okay, so if I times by 4, I get 2 times 4 is 8. And the antiderivative was arctangent of x minus 2 over 4 plus c. Okay, when you get to 6.14 is just a really nice review of all the different techniques we've used. So try that homework for practice for sure. It's good practice deciding which method works in which situation.